Let's do a third example of an inexact neutralization question. This last example is a little bit more challenging because it's worded differently again, and it's actually a question that involves us working backwards compared to what we've done previously on these types of examples. So let's read the question. How many grams of hydrochloric acid, HCl, must be added to 40 mils of 0.180 molar sodium hydroxide to produce a solution having a pH of 12.5? And we can assume there's no volume change here. In other words, when you add the HCl to the 40 mils, it's not making the volume any greater. The volume change is negligible, or it's very, very small, so we can ignore it. So when we look at this question, again, it's a neutralization because we've got HCl, a strong acid, added to a strong base. And when we think about those neutralization reactions, let's remember that what we're really doing is we're adding some H plus to some hydroxide ion to form water. That's at the heart of this neutralization reaction. That's the net ionic equation. And so in the end, we're producing a solution that has a pH of 12.5. This is basic. So there's some important information that we have to unpack here. And the first is that after the neutralization, we have excess hydroxide ion because that's a basic solution. So that tells me that this is in excess. So we're going to react all of the H plus that's provided by the HCl with an equal amount of hydroxide ion from the sodium hydroxide, and then there's still going to be some hydroxide ion left over, enough that it gives us a pH of 12.5. So in this question, what we're really trying to find is how many grams of HCl we added, and really working backwards then, we're trying to find out what is the concentration of H plus, and then from there we can find the grams of H plus, or in other words the grams of HCl. Okay, so we're working backwards a little bit in this question. So we can start by determining what is the H plus concentration. This is a good place for us to start here. So let's go ahead. We are going to be able to figure out the excess OH amount, and from the information given in the question, we're also going to be able to figure out the starting amount of the hydroxide as well. So let's go ahead and do that. So let's remember that to find the excess of either H plus or OH, normally, generally speaking, we would have the following. We would say that the concentration of OH minus in excess is equal to however much OH minus we started with, which we can figure out because we know the concentration of the base and the volume of the base. We have all the information there that we need. Okay, so it's going to be the starting concentration of OH minus the concentration of the H plus, because the H plus would have reacted with an equal amount of the hydroxide, and we would have had some leftover OH minus. So this time we're working backwards because we can solve for this guy right here, and we can solve for the starting amount from the base, the concentration of the base that we're given. So we're actually now looking for the H plus concentration. So let's rearrange this this expression so that we're solving for H plus. So I want to isolate H plus. So it's going to be equal to, if I move that over to the left hand side and I have to subtract from both sides the OH excess, I will get H plus is equal to OH minus starting, okay, minus the OH minus in excess. Now we can start by solving for the OH concentration starting or the concentration of OH minus in excess. Doesn't matter, either one. Let's just go ahead and we'll start with this one right here, the concentration of hydroxide ion in excess, because that's a really straightforward calculation. So our first step is going to be that we want to find the concentration of OH minus in excess, which, by the way, is simply how much was left over after the reaction. And that comes from the information that we're given, which is that the pH after the acid is added to the base is equal to 12.5. So I need to go from pH all the way to concentration of OH now. And so the first thing I could do is I could start by solving for the POH. So the POH is going to be equal to 14 minus the pH, which is equal to 14 minus 12.50, which is equal to 1.50. Making sure that I keep track of my sig figs here, and I should have 2 sig figs after the decimal place, or 2 decimal points here. Okay, so now that's a POH value, and from POH I can calculate the concentration of OH minus. Okay, I'm going to take the anti-log of the negative POH, and so the anti-log of negative 1.50 is equal to 0.03162, leaving some decimal places here. 0.03162, that's now a concentration, so moles per liter, and I will keep track of my 2 sig figs here. Okay, right there, so 3 in the 1. And this is my concentration of OH minus. And since this POH and the pH corresponded to the resulting mixture after the acid and base were mixed, this is my excess amount, because this is how much hydroxide ion is present after everything was mixed together. So I've solved for this one up here, and now I need to go back and figure out when I first mix these together, what concentration of hydroxide ion did I introduce into the solution. So I'm looking for the concentration of hydroxide ion starting, or in other words, the concentration of hydroxide ion right after the dilution, so before it has a chance to react with the H+. So this is the starting concentration. And we do need to be, if there was a dilution, we'd have to be aware of it. In this case, we're told that the volume doesn't change when we add the grams of acid, and so we don't have to do a dilution calculation, which is nice. But we do need to still find out what is the concentration. And so here's the information that we're given. We have sodium hydroxide, that's our base, and we're given the molarity, it's 0.180 moles per liter, and we know that there's 40 mils of it. However, in this case, because there's no dilution, the 40 mils isn't going to impact the concentration of the hydroxide, because whether I have 100 mils or 30 mils or 40 mils, I still have the same concentration of base in all those different volumes. So you got to be a little bit careful sometimes with the amount of information that we're given and what we really need for every specific calculation. So here, because I have a concentration of sodium hydroxide given to me, and there's no further dilution, I don't need to perform any dilution calc, and I don't need to use that volume. Not for this anyways. So I have 0.180 moles per liter of sodium hydroxide. I'm going to write that underneath, 0.180 moles per liter. And I can go ahead and just dissociate this strong base. It's going to give me sodium ion and hydroxide ion, and so it's in a 1:1:1 ratio, so that means that I also have 0.180 moles per liter of the sodium hydroxide initially. Okay, so the next step then, because I've now solved for the starting concentration of hydroxide and the excess, now I can go ahead and use this, and I can calculate the concentration of H+ that was present in this resulting mixture. Okay, so let's go ahead and use that right now. So I've written it down again below, and I'm going to go ahead and plug in these concentrations for the hydroxide ion now. So initially I had 0.18 moles per liter, and I'm going to subtract the excess, which was 0.03162 moles per liter, and I am going to underline my sig figs just so that I can keep track of them. I've got 3 sig figs in the first value, only 2 allowed in the second value, and so I just want to make sure that I use my addition subtraction rule, and I should be allowed to go to a total of 3 decimal places in my answer. And so this is going to come out to be equal to 0.1484. Again, I'm not rounding yet, just keeping track of sig figs, and I'm going to be allowed to go to 3 decimal places, so up to the 8 there. And this concentration is equal to the amount of H plus that was present. Okay. Now, I'm in concentration, this is moles per liter, and where I want to go is to grams. I want the grams of HCl that I added. So I've just got to work through this. I'm in moles per liter. I can get to moles because I do know the volume of this solution. It's given to me. That's where we do now need to use that volume of 40 mils. So I can go ahead and multiply by volume to get into moles, and then once I'm in moles I can get to grams using the molar mass of HCl. So let's go ahead and just work through those calculations. So I want grams, so grams of HCl is equal to what I have, which is 0.1484 moles per liter. I'm going to go ahead and write this, instead of in capital M, I'm going to write this as moles per liter. Okay, just to keep track of my units. I'm going to multiply by the volume. The volume is given to me in milliliters. I need to go ahead and change that into liters so that I can cancel those units. And in this case, without going up to the top of my screen, it was 40 milliliters. So I'm going to go ahead and change that into liters. So that's 40 mils. If I divide that by 1,000, 1, 2, 3, okay, that's equal to 0.0400 liters. So that's going to cancel my liters. Now I'm in moles. And finally I can go ahead and I'm going to use the molecular weight of HCl to get from moles to grams. So I need to calculate that on the side as well. So here's some of my little side calculations over here. So the molecular weight, or the molar mass, of HCl is equal to the mass of one hydrogen atom, which is 1 plus 35.5 chlorine. So that's equal to 36.5 grams per mole. Grams per mole. So here where I want to convert, then I'm going to make sure I put the 36.5 grams on the top of my conversion factor and the 1 mole goes on the bottom. So I'm multiplying by molar mass or by molecular weight, whatever you want to call it. And so my answer is going to come out here to be equal to, let's do the math, we come out with 0.217 grams of HCl. And before I round this off, I do need to have a quick look at my sig figs for a moment. So here in my first value I was allowed to go to 3 decimal places, so there's 3 sig figs there. There were also 3 sig figs in my volume, which is significant. I don't worry about the molar mass. Actually, that's not true. Our molecular masses are, we can count those because they are averaged amounts, and our periodic table rounds them. So you can find a periodic table that gives you more precise masses. But again, we have 3 there. And so in total, we're allowed to have 3 sig figs in our answer. And so 1, 2, 3 sig figs is our answer right there. So our grams of HCl that had to be added was 0.217 grams of HCl.